Hello, and welcome to a little video about the Unit 6 test review. Let's get to it. Number 1 asks us which of the inequalities would be represented with a dashed line. Select all that apply. So take a look at all the symbols. What do you think? The correct answer is B and D. Number 2 asks us which of the inequalities would represent a graph with a solid line. Select all that apply. Take a look at the options. What do you think? Your answer should be A and C. Now, this is how I remember. Symbols with solid lines underneath them create solid lines, because that solid line under the symbol is kind of like a part of the equal sign. And when we graph y equals, so just regular linear equations, we always use a solid line. That's why the graph of an inequality with a solid line underneath it is also solid. Number 3, write an inequality that is represented by the graph. All right, well, first, we already have a y there. Perfect. You know what? I'm going to rewrite it because my handwriting is big. So, y. First, I need to decide on the symbol. What I notice about the line is that it's solid. So my symbol will definitely have a solid line underneath it. Next, I'd like to decide if it's a greater than or less than symbol. The way that I decide on that is I put my pen, pencil, finger, whatever it is, on my y-intercept, and then I drag my finger, pen, pencil up towards or down towards the shaded area. This time, it looks like the shading is going up above the y-intercept, which means y is greater than. Okay, now let's count the slope. It looks like we're going up 1, 2, and to the right 1. So, So our slope is 2 over 1. Let's put an x next to it. And then our y-intercept is -5. That's it. Let's try that again in number 4. First, let's select some points. I'm going to put one right here on this y-intercept, and then this next little corner. Okay, y. The first thing that I notice about this graph is that the line is dashed. That means that inequality symbol will not have a line underneath it. Now let's decide if it's greater than or less than. Just like before, I'm going to draw an arrow towards the shaded area. So in this problem, when I draw an arrow towards the shaded area, it's going upwards. So y is greater than. Now let's count the slope. It looks like I'm going down 2 to the right 1. So -2 over 1 with an x next to it. And our y-intercept is 4. So +4. I didn't mean to choose pink. +4. And yes, I know there's no 4 written on the graph, but just imagine. Beautiful. Number 5. Graph the following system of linear inequalities on the graph below and then answer the questions. All right, let's do it. I'm going to begin with, that's not what I wanted to begin with. Let's try that again. I'm going to begin with color coding. So I'm going to do this top equation in pink. Sorry, inequality in pink. All right, the y-intercept is 4. The slope is -1. So remember, -x is actually -1x, and -1 is written as -1 over 1. So down 1 to the right 1, and I make another point. Now that we have our points, let's see how we're going to connect our line. We have a less than symbol. That means we're going to have a dashed line connecting our points. I'm going to do a couple more points because I don't have a nice straight edge to use on my computer. Okay, dash. Y is less than. That means I'm going to be shading below my y-intercept. Below means downwards, and I'll be shading here. It's definitely the end of the school year. Now you can do this in just gray pencil for both of them. I think it's so much easier if you do at least one other color. So I have colored pencils available, or bring your own, at least one other color. So you can use your gray pencil and then one other color. Next, let's graph the second inequality. I'm going to do this in blue. This one starts at -4. The slope is 3, which is 3 over 1. So I'm going to go up 3 spots to the right 1 spot. We have a greater than or equal to symbol. The solid line underneath the symbol reminds me that I'm going to connect my points with a solid line. Now, of course, you can have a straight edge and do that right away. I'm going to make a couple more points, so I'm going to keep going up 3 to the right 1, up 3 to the right 1. This will just help make my straight line nicer as I freehand it. Okay. Y is greater than. That means I'm going to be shading above my y-intercept. Above means upward, so I'm going to be shading everything above this blue line blue. That means we will be overlapping with the pink, which is good. That means there are solutions to this system. So the overlapping part should look kind of purplish to you, I hope. It looks purplish to me. Our solutions are allowed to exist where our colors overlap. So that's why I think it's good to use at least one other color while doing this. And our solutions are allowed to exist on a solid line that borders the shaded area. Okay, let's see what these questions are. Is 1 comma -1 a solution? Why or why not? Okay, 1 -1, so I'm going to go right 1 down 1, and I land right here. I don't know if you can see that. Let me do that in black. There we go. That's 1 -1. That lands on a solid line bordering the overlapping area. So, yes, it lands on the solid line bordering the overlapping area. Okay, next one is 1 comma 3 a solution, all right? 1, 3. Ooh, this one here. Nope, it's not a solution because it lands on the dashed line. Doesn't matter if it's bordering or not. We can never ever land on a dashed line. So no, it lands on the dashed line. All right, let's try that again in number 6. I'm going to use blue and pink again because I like how it turns out purple. It's my favorite color. All right, first inequality. I'm going to start by putting a point on -2 because that's our y-intercept. Our slope here is -1 over 1. So I'm going to go down 1, right 1. I'm going to make a couple more points. Okay. We have a greater than symbol, which means I'm going to have a dashed line. Because it's greater than, I'm going to be shading above the y-intercept. Above means I'll be shading this whole area. I'll make the highlighter bigger. Oh, ooh, I can't. That's so much faster. Okay, nice. Okay, second one. Let's do that in blue. This one starts at +2. Our slope is -5, which is -5 over 1. So we're going to go down 1, 2, 3, 4, 5 to the right one. All right, looks like they, so we have a less than symbol, which means we'll be connecting it with a dashed line. Oh, that, okay, that was not that straight. I promise it looks so much better on my physical copy. Anyways, it's less than, which means we're going to be shading below the y-intercept. So down goes my arrow. We will be shading this whole part. Oh yeah, I can make this larger. Let's do it. Yes. Then it is so much better. So much faster. Alright, let's make it small again. Is negative 3, 1 a solution? Let's check it out. Negative 3, 1. Nope. It's on a dashed line. No. It lands on the dashed line. Is negative 2, 3 a solution? Negative 2, 3. Yes! It lands in the overlapping area. Beautiful. Number 7. Ooh, we're going to write a system of inequalities. Mr. Miller wants to throw a brunch for some friends. Bagels cost $1.75 each. Muffins cost $3 each. He can spend at most $70 on food. He needs to buy a total of at least 32 bagels and muffins to have enough food for his friends. Let's write a system. Okay, so what do we have? We have two unknowns, bagels and muffins. I'm going to say that x equals bagels and y equals muffins. Okay, bagels cost $1.75 each. The way I would write that is 1.75x. Muffins cost $3 each, plus 3y. He can spend at most $70. All right, let's decide on the symbol, because it's not equal 70. Can he spend less than $70? Sure. Can he spend more than 70? No, at most. 70 is the maximum. So his spending, the $1.75 for bagels and $3 for muffins, has to be less than $70. Can he spend all of his money? He can. So it's less than or equal to. He needs to buy a total of at least 32 bagels and muffins. Ooh. Bagels and muffins. Ah, man, I don't have enough colors. How am I going to do this? We're just going to have to improvise. All right. So, oh, I know. Bagels and muffins. The way we write bagels and muffins in math is x plus y, because that's what bagels and muffins are. He can buy a total of at least 32 bagels. So we know there has to be a symbol and then a 32. Well, let's think about it. Can he buy less than 32? No, because 32 is the least, it's the smallest amount. So he wants to buy more than 32. Okay, so then bagels and muffins should be bigger than 32. At least 32 means he can get 32 and that's okay, but he should probably get some more. So, or equal to. Number 8. Ken makes cakes and pies. Hold on, I want to switch my color back. Ken makes cakes and pies. It takes him 6 hours to make a batch of cakes and 16 hours to make a batch of pies. He has 206 hours available to make cakes and pies. The cost of producing each batch is $15 for the cakes, $40 for the pies. The ingredients to make the cakes and pies must cost at most $515. This is the system that represents it. What does 511 represent? Okay, well, first and foremost, I want to remind us that when we write a coordinate, it's always x and y. So I need to find out what is x and y, because like in number 7, x was bagels, y is muffins. So what is x and y in this one? Well, let's look at the inequality. For x, I see 6x and 15x. What does 6 connect to in this problem? It looks like it's connecting to 6 hours for cakes. And what does the 15 connect to? 15 for cakes. Okay, so my x's represent cakes. I'm just going to write that on the side. X equals cakes. All right, well then, we have 16y and 40y. We only have two things, but let's still look at the problem. We got 16 hours to make pies and $40 for the pies. So our y is pies. So what does 511 represent? 511 represents the amount of cakes and pies. Ken made 5 cakes and 11 pies. That's what 5, 11 represents. Let's do another one. We got Olivia making small and large sweaters. It takes her 25 hours to sew a small sweater and 65 hours to sew a large sweater. Olivia has 1,215 hours to sew sweaters. The cost of producing the sweaters is $5 for the small and $13 for large. The materials to make the sweaters must cost at most $243. This is the system. What does 716 represent? Well, our coordinate is x, y. Let's check out the x's. With the x, I have a 25 and a 5. It takes her 25 hours to sew small sweaters and $5 for small. Okay, so x is small sweaters. I don't feel like writing sweaters. I should do it. I'll do it. And y, we got 65 and 13 that go with y. 65 hours to sew large sweaters and $13 for large sweaters. So y is a large sweater. So what does solution represent? Olivia made 7 small sweaters and 16 large sweaters. All right, I want to rewrite that though. There. Okay. Not bad. Let's see what we've got next. Number 10, let's complete the system of inequalities for the graph at the bottom of the page. All right, this is what I do when I look at this. For you, on your page, this is going to look different. You're going to have a light gray on the top and bottom and dark gray where it meets. Okay? The darker area is where things cross over. For the first inequality, I have a y-intercept of -2. So let's find -2. Here it is. The first thing I notice is that it's dashed. So that means our symbol will not have a line underneath it. Now I'd like to see, where is the dark gray part, or on my paper it's purple. In order to find that out, I put my pen, pencil, or finger on my y-intercept and I pull my finger towards that darker area. It looks like we're up, which means y is greater than 1/3 x minus 2. Well, there's only two inequalities, so still, I'm looking at this y-intercept of 3. Here it is. It's a solid line, which means I'm going to have a solid line underneath my symbol. On your paper, once again, we're going to have a dark gray and a light gray. We want to see which way do we drag our fingers from the y-intercept to get to the dark gray area. It looks like we're going downwards. So that means we have a less than or equal to. Number 11. Is each point a solution to the graph below? Why or why not? Okay. 0, 0. Here it is. That's letter A. That is a solution. Yes. It's in the overlapping area. You could say darker area, but overlapping would be more accurate. Letter B is 6, -1. 6, -1. No. No. It's not on the shaded. No, I think on the overlapping area. 3, -1. Let's see. 3, -1. Nope. It's on a dashed line. Whoops. No. It's on a dashed line. And finally, letter D, 0, 3. Oh, that's right here. That's this y-intercept. This would be yes. It's on the solid line bordering the overlapping area. And that's all she wrote. I hope that this felt like an easy unit. From what I've seen, you guys have been doing great. At least I can speak for my students. If you have any questions, please make sure to ask me or whoever else is helping you out in math. And have a wonderful, wonderful rest of whatever day it is for you. Get plenty of rest. I'm gonna do that. Bye.